So we're on page 409 in your workbook and looking at division of rational expressions. So remember, to divide fractions, what is it that we want to do is we want to multiply by the reciprocal of the divisor. So that's the second term. So I know in the workbook and in my copy, scanned copy, it looks like an addition symbol. These are all division symbols. So anything that kind of looks like addition right now, it is division. So in this particular case, yes, I know it's very tempting to reduce here. You can only reduce when it is in multiplication. So at this point, our very first step then is to kiss and flip, as some people think of it as well. So 7 times the reciprocal, which is 14/3. And then at this point, rather than multiplying across straight away, this is now where I can reduce. So 14/10 is the same as 7/5. And then we're just multiplying it across. So then that gives us 49/15. Sometimes we look at certain numbers and you're trying to think of, oh, is there a common factor that I can divide? If you can't tell, go back to its factors. 7/5, that doesn't reduce. 7/3, that doesn't reduce. If I was to trade the numerators around, it doesn't make a difference. And so 49/15 is in lowest terms. In this particular case, we've got 6/5 divided by 9/10 times 1/20. Because of order of operations, we're going from left to right. So 9/10, that is your divisor. So what I can do then is I can look at this as 6/5 and multiplied by the reciprocal, which is 10/9 multiplied by 1/20. And even though order of operations would say start left to right, I can actually switch any of them around since it's all multiplication. So at this point, I could see this as 10/20 is the same as 1/2, and I can say that 6/2 is the same as, 6/2 is the same as 3/1, and 3/9 is the same as 1/3. So now I've got 1 times 1 times 1, which is 1/5 times 3 is 15. So 1/15 is my answer. For C, I am dividing by this product. So if you imagine, this will be 9/200, and so then we'll be reciprocating that to dividing by 9/200ths or multiplying by 209ths. So because of that, what I can actually do is multiply by the reciprocal of the whole thing. So if you're not sure about what I've just done, then you can always just do the brackets first as in order of operations. But my goal is to try to reduce as much as possible first, so I don't have to worry about multiplying sometimes what will be some big numbers. So we know that 10/5 is the same as 2/1, and 6/9 can be reduced to 2/3. So nothing else can be reduced here. So 2 times 2 times 20 is 80, and 1 times 3 times 1 is simply 3. So 80/3 is our answer in that case. So extending that to monomials, really no difference other than the fact that we need to do some restrictions. But it says at this stage we won't worry about restrictions. They go through that in a little bit of an exercise below that. So let's take a look at this first. So we check 16a 9b squared. Can that fraction be simplified? No. Same thing with 32a squared over 15b. No common factors, so I'm going to just go ahead and reciprocate and multiply. So 15b over 32a squared. Switch a color. And so now we've got 16/32 is the same as 1/2, and a over a squared, that takes away one of these a's. 15/9 can be reduced by a factor of 3, which is then 5/3, and b over b squared, we take out one of these b's, in which case we're left with 1 times 5 over 3b times 2a, or 6ab, keeping those variables in alphabetical order. In this case right here, because we've got some multiplication happening, we can see that there's a couple places that we can reduce. So I'm going to reduce first, even before reciprocating right here. That way I don't have to write everything out. And so we can see that this z will cross off with one of these, so that will leave me with z squared. There, the 5 over 15 is the same as 1/3. And this x and this x can reduce as well. So that cleans it up. I can't do anything with this one just yet because it's still in division. So let's rewrite what I have and as well switch that into division. So now this new and improved is -1 y cubed over 7z squared times 2 over 3x multiplied by the reciprocal, which is -21 z to the 4th over 10x squared y squared. So let's take a look at what we can simplify now. So any numerator with any denominator, since it's all in multiplication. So we've got 21 over 7, which is 3 over 1, and then 3 over 3. Those cancel out. When I look at y cubed here, I've got y squared, so we can take all of the y squareds, 2 of those ones out, so leaving me with y to the 1. And then z's, we've got 2 z's down here, and that takes out 2 of these ones. And x's are both in the denominator, so nothing that we can do right there. And the 2 over the 10 makes that 1 over 5. So you can see that this can get pretty messy. So be sure that you can read your own writing. Be sure that you can keep track of everything. If not, then you do that in multiple steps. Okay, at the same time, I want to keep track of my negatives. Even up here, I can see this is all multiplication and division. There's only the 2 negatives, which means that my answer is going to be positive. So I keep that part in mind as well. So cleaning things up, now in this particular case, I've just got negative y in the numerator, and but again, negative, negative, that's going to make a positive. So I've just got y and z squared, so y, z squared. And then in the denominator, the only thing that I have left is 5x squared and another x, so then that'll give me 5x cubed. So that's your simplified answer at this point. So let's take a look at the non-permissible values when it comes to division. So if you take a look at a over b divided by c over d, where a, b, c, and d are obviously variables. So for the first expression, a over b, the non-permissible values, of course, that b cannot equal 0. For the second, our divisor, obviously we're looking at d cannot equal 0. The first step is to invert or reciprocate the divisor, and so then we have d over c. So now all of a sudden your c is also in the denominator, so c cannot equal 0. So the summary on the next page, and so for a division of the type a over b divided by c over d, we need to consider all of b, c, and d. So we need restrictions for all 3 of these. Anything that is ever in the denominator at any point in time needs to have restrictions stated for it. Okay, so if you look at class example number 3, all there, it's the same numbers, same questions that they used for class example number 2. So they're just asking you for restrictions. So looking at this, we know that b cannot equal 0. When I look at this, I know that a cannot equal 0. And here, again, b cannot equal 0. We've already got that. In this particular case, we're looking at this denominator. So x cannot equal 0. Z cannot equal 0, and all of these are just simply cannot equal 0. Why? Because they are just the factors. There's no binomial factors that we're dealing with. It's 7 times x times z. And then in this particular case, again, it's x 15 times what? 15x can't equal 0, therefore x can't equal 0. For this one, we're looking at z again, cannot equal 0. Now we go to the numerator, and we also need to include the fact that y cannot equal 0. Okay, because that is part of our divisor there. Okay, let's move on to the next one then. So, looking right here, so where it is division, again, we can simplify in any given expression, so that for this first fraction, if there is something I could reduce, I would. Same thing with the second one, there isn't, and therefore the only thing I can do is reciprocate and multiply, so this flips, so x plus 1 over x minus 2 times x plus 3 times 2 times, whoops, didn't reciprocate, x over x plus 3, x times x plus 3 over 2 times x plus 1. So at this point, then everything is factored. So we've got x plus 1 over x plus 1 is 1 over 1, and x plus 3 over x plus 3 is 1 over 1. So now all I've got left then is x over 2 times x minus 2, and that is contingent on my restrictions. And looking at these factors first, oops. So looking at these ones, we've got negative 3 and positive 2. Looking at these ones, we've got 0 and negative 3, and looking at the numerator, negative 1. So again, we've got more and more each time, and so that's why it's really important to try to put them into some kind of an order that will help the person who's looking at your work find everything that they need to see. So x cannot equal negative 3, negative 1, 0, or 2. Have I got them all? So 2, negative 3, 0, negative 3, negative 1. Excellent. Okay, for part B, it's really just the same thing. They just kind of make it look not pretty in a complex fraction. So what are we dealing with is we're looking at 4x plus 12 over 3x plus 12. And that is divided by 3x squared plus 9x over x plus 4 all squared. So we've got a couple of things to do. We have to factor, and we also have to multiply by the reciprocal. So we've got 4 times x plus 3 over 3 times x plus 4 multiplied by x plus 4 all squared, and that is over 3x times x plus 3. So taking out your common factors, we've got x plus 3 over x plus 3, x plus 4, and that takes out one of these factors here. These 3's are both in the denominator, so we can't do anything with those. So our answer then is 4 times x plus 4 over 3 times 3x. So I will multiply that out to make that 9x. And my restrictions again, so based on the factored forms, and now I'm looking right here, I've got negative 4, negative 3, 0, and then this one right here, which was our denominator here, which is negative 4. So we've got negative 4, negative 3, and 0 are our restrictions. Okay. Next page then, now it's getting fun. So again, so take a moment, factor these, and then come back for the solution. So just hit pause as you factor. Okay, so hopefully you've double checked all of your factoring, you've made sure it's all correct before you start canceling away things that aren't actually there. So, taking a look at example A, we've got lots of good stuff to factor, so this is fun. So we can take a look, and we've got a common factor x minus 3 and x minus 3, x plus 3 and x plus 3, and x plus 1 and x plus 1. Conveniently, we've also got an x here, and we can take that with one of the x's from the x squared. So that simply leaves us with 4 over 7x. Easy as that. So our restrictions, so taking a look at the first one, we've got plus and negative 3. We've also got from this the bottom one, which is now the top here, negative 3 and negative 1, and from here 0 and negative 1. So negative 3, negative 1, 0, and positive 3. Taking a look at this second one, and so if you're not sure why I reciprocated everything the way that I did, please refer back to, just hit pause right now and look back to example number 1C on the last page. So let's get back and let's take a look here. So we've got 2m plus 3, 3 plus 2m, those are just exactly the same. And then we've also got 2m minus 3. That is exactly opposite to 3 minus 2m. Because a 3 is positive, 2m is negative, 2m positive, 3 is negative. So this is 1 and this is negative 1. And then in this particular case, we've got m and m. 10 and 11, of course, don't reduce. And then we've also got m plus 1 and m minus 1, and this is our difference of squares, m squared minus 1. So I could use another line to factor those, but I already know that m plus 1 times m minus 1 make my m squared minus 1, so I can take that out. So I'm simply left with then 10 times negative 1 in the numerator, so negative 10, and the denominator is going to be 11 times 2m plus 3. And in terms of restrictions, there's quite a few of them to do. So we've got, and in some cases it means maybe making a note to the side and then putting them in order. So in this particular case, we've got m cannot equal negative 3 halves. We've also got, what else? Negative 1, 0, positive 1, and positive 3 halves. And I think that's captured all of them. Great. Let's take a look at class example number 6. So this is a nice one. Before we can actually divide, because remember you are dividing this whole numerator by the denominator, and so that means that you need to bring them into essentially one fraction or one rational expression, which means this is a nice question combining addition and subtraction with your division. So for that numerator, we need a common denominator, and what is our common denominator? It's going to be a times 2a plus 1. So we've got common denominator of a times 2a plus 1, and so the 10 has to be multiplied by the 2a plus 1. It's a little bit longer, and minus, and that 12 needs to be multiplied by the a, and this whole thing will then be divided by and common denominator of a. So we've got 5 plus, and then 4 is over 1, so top and bottom needs to be multiplied by a, so 5 plus 4a then. So let's clean up the fraction on the left first. So we've got then 10 times 2a plus 1. And why do I need to multiply that in? Is because I need to be able to combine that with that minus 12a, so that it's just multiplication, or it's one single binomial. So then we've got 20a plus 10 minus 12a all over a times 2a plus 1. I'm not going to distribute that in because those are already factors, and I can now reciprocate this times a over 5 plus 4a. Clean up that top there, so 20a minus 12a is 8a, so we've got 8a plus 10 over, and we can already see that those a's, because it's multiplication, those a's will cancel out as 1 over 1, so I won't write that one again. And we've got 2a plus 1 times 1 over 5, 5 plus 4a, and the numerator, conveniently, we can factor out, take out a factor of 2, so 2 times 4a plus 5, that's convenient, over 2a plus 1 times 1 over 5 plus 4a, and those cancel out, so we're left with 2 over 2a plus 1. And no, you cannot take out those 2's, because that 2a plus 1 is combined as a single binomial. So simply restrictions now, so a cannot equal, and going all the way back to anything that was ever in my denominator. So in this case, a cannot equal 0, it cannot equal negative 1/2, in this case 0 again, and right here we've got 5 plus 4a in the denominator as well, so that's going to be 5 plus 4a cannot equal 0, or a cannot equal negative 5 quarters. So we've got negative 5 quarters, negative 1/2, and 0. I think that's all of them. So, excellent. Continue on with your work.